Okay, chapter number 5, CCENT. We're going to be covering configuring a network operating system, which basically means how do I use Cisco IOS, the Inter-Network Operating System. Now, before we actually get into some of the specifics about Cisco IOS, let's learn some of the basics. First of all, it is an operating system. It's loosely based on a Unix or Linux platform. There are variations in different flavors of Cisco IOS. There's the traditional iOS. There's the Cat OS, which is something that we saw way back in the day. There is NXOS for the Cisco Nexus platform. There's iOS XR and iOS XE. So lots and lots of flavors of Cisco IOS. But for the most part, we're going to focus our attention on the standard Cisco IOS operating system, which is what is deployed on 90% of Cisco gear. All right. The nice thing about Cisco IOS, it is a standardized platform. So yes, there are different versions. There are different flavors. There's voice-enabled versions and security-enabled versions. But fundamentally, the configuration is the same regardless of the the device that you're configuring, whether it's an access point, a router, a switch, etc. All right, so it's important that we understand how to navigate through the iOS, how to understand some of the basic concepts, so that when we start to do more and more advanced configurations a little bit later on, it will make more sense. Okay? Now, the goal of this class is not to teach you guys how to configure everything. It's impossible. There are literally tens of thousands of commands that are available. But I want to give you guys the knowledge and the tools necessary so that you can figure out what it is that you're trying to do based on that knowledge and based on that understanding. All right? Now, the iOS itself, the operating system, is stored in a memory location in the Cisco device, whether it's a switch or a router, called flash. Okay? Flash is basically, you can think of flash as pretty much a hard drive, a solid-state hard drive. It's usually either an external compact flash card, as you can see on the picture on the left, or it is a DIMM that goes inside a slot on the motherboard that stores our operating system. Okay? Now, the flash is not just used to store operating systems. It's also used to store firmware files and other files that the system might use. If it's a voice router, for example, it'll store ringtones and firmware files for phones and so on. All right? This flash is non-volatile, meaning whatever's stored in it stays there even if the device is powered off. So it's essentially a hard drive. That's basically what it boils down to. Just like your computer, we don't run the operating system from the hard drive. We run the operating system from working memory. So when a router or a switch boots up, the iOS is extracted from flash and ran or executed in working memory. Okay? Oftentimes in a router, you'll see that that's called the DRAM, especially for Cisco. So when you go to Cisco's website and you go to download an image, one of the things that Cisco will always tell you is how much working memory, DRAM, and how much flash you need for that particular image to run. All right? Flash is a type of memory in the router or switch, and DRAM is a type of memory in the router or switch. Sometimes you have to upgrade those memory components in order for that particular operating system to function. Does that make sense? Okay? All right, I'm going to show you some commands later on. I don't want to do it right now, but I'm going to show you some commands later on to help kind of navigate through these different functions. One of the most confusing things about Cisco IOS, though, is what iOS does what. In other words, what features are included. If I upgrade the iOS, what features am I adding or what features am I losing, et cetera, because it can be very confusing. One router platform might have hundreds of different images that you can choose from. So Cisco has a tool on their website called the Feature Navigator tool. You can see it says there, welcome to Cisco Feature Navigator. And you can see that you have the ability here to do things like research the features that an operating system might have. You can look at the platforms that are supported by that operating system. You can compare two different software releases. So maybe you're in software version X and you want to upgrade to software Y. You want to make sure that you're not losing features or you're not carrying additional features that might require licensing or something like that. Also, there are end-of-life images and so on. End-of-life means Cisco has chosen to no longer support those particular images. All right? Now, when you get a device like a router or a switch, this happens to be a 1941 series router. When you get a router or a switch, there are three unique ways that you can configure that device. You can configure that device through the console port, and you can see the light blue box around the console port, micro USB or RJ45 connector. The console port is an out-of-band management port. What does that mean? What does it mean for the management to be out of band? It means that it is a port specifically dedicated to configuring and managing that device. No user's traffic flows over that port. So the console port initially is the port that we use to configure our devices. Right? When you get a Cisco router or a switch or an access point or any kind of device, it almost always will have some sort of console port. Now, once the device is on the network, once you've gone through and you've configured the device for operation and it's attached to the network, you can now manage that device in band, meaning you can use SSH or Telnet to gain access to the device so that you can start configuring it. Does that make sense? That's what we call in-band management. So I can go through my Ethernet ports, through Telnet, through SSH, and go into the device that way. In addition, some Cisco devices actually have a secondary out-of-band management port called the auxiliary port. That's the one that has the black square around it, right? Now, an auxiliary port is essentially the same thing as a console port. Fundamentally, it's the same thing. The auxiliary port uses the same protocol to communicate, RS-232, and it's an out-of-band port. But the auxiliary port operates at a much higher speed than the console port. We'll learn more about what the auxiliary port is used for in a little bit. Okay? So initially, when you get your device out of the box, 99% of the time, there are some Cisco devices that don't have this function, but 99% of the time, you're going to get a serial cable. You can see a little picture of the serial cable in the right corner here. This serial cable comes with the device. It's called a rollover cable. And you'll plug that into your console port, and you'll start doing your configuration. Yes, sir?
So one end in the switch and the other end, for example, on the computer to operate through it?
Yes. So the RJ45 end would go into the port, and the DB9 end would go into your laptop. Usually you'd have to get some sort of adapter, right? USB to serial adapter, which you can get just about anywhere these days. They actually make cables now that are USB to RJ45. So you can get those on Amazon for a few bucks. They're not too bad. And it's much more convenient than trying to have some adapter that needs some weird drivers that your Windows operating system is not going to support, right?
One more question. It's not
Sure.
way out of the topic. Which Cisco router that you recommend for us to just buy it and play with it and try to configure?
Okay, so the question was, what kind of router would I recommend that you buy to play with? Two factors. Number one, don't get 2600s or anything like that. Those are very, very old. They're going to be very limited. You generally want a router that's going to run 15 code, 15.x, and in the 900 series, right? So 1900, 2900. Although I will say the 2800s are not bad, like a 2821 or a 2811. Not bad, but the 1900s are going to do a lot of the stuff that you need to do. The problem with you go to the 1900, though, is the licensing is a little bit different. So in a nutshell, 2800 series or 2900 series. Yeah. Or 1900 series. Yeah. In the 900 range, right? Those are some good devices. Okay? As far as the interfaces and whatnot, it just depends on what you're trying to do. If they're going to have serial interfaces or Ethernet interfaces and so on. Okay? The 3750 is okay. It does layer 3, but not, it doesn't do serial. It doesn't do a lot of the things that you want to do on a router, like IPSLA and stuff like that. I mean, it does have some IPSLA functionality, but even though it's layer 3, it doesn't do all the routing stuff that you might want to do. Okay? So when you get these devices, you want to configure them for the first time. You're going to connect with the console port. Okay? Now you'll notice on the right side, the properties, bits per second, 9600 bits per second. That doesn't sound like a very quick speed, but you have to understand this is just really just serial communication. We're just sending ASCII characters back and forth to the platform, so it's not high bandwidth stuff. So 99.6 kilobits per second is just fine. The console port is fixed at that value, so you don't want to try to adjust it unless you adjust the console port settings, which you can do, but most people don't. All right? Now, I have noticed for certain types of platforms, and you guys may want to make a note of this, that the flow control, sometimes you generally set it as none, but sometimes you need hardware flow control. If you connect to your device and you're not getting a response from your console, usually I've found that switching to hardware flow control fixes that problem. Okay? Usually we leave it on none, but sometimes you can switch it to hardware flow control. This is the flow control setting. Everything else stays the same. Okay? Now, once you connect your console port, your console cable, essentially now you can start configuring your device. Most Cisco devices have very limited configuration on them out of the box. Routers, for sure. Routers have very little configured on them out of the box. There isn't a whole lot that a router has going on out of the box. So you have to configure a lot of those settings. Switches, on the other hand, out of the box, tend to run, but they don't have VLANs or anything else configured on them. Okay? Once the device has been configured and you've established connectivity for that device on the network, then you can use Telnet or SSH to access the device, meaning you're accessing it over the network. All right? Now, Telnet is the default in-band transport. The problem with Telnet, though, is it's not very secure, right? It sends everything in plain text, the authentication, and whatnot, not very good for Telnet. So we will teach you guys how to switch from Telnet to SSH. We're going to teach you guys how to switch from Telnet to SSH. All right. SSH is secure shell. SSH uses encryption for confidentiality, and it has a much stronger authentication process. Now, the aux port is generally used to connect a modem to your device. You will see this if a service provider installs a device that they manage on your premise, they will connect a modem to that device because they want to be able to dial into that modem and gain access to that device as if a technician is physically there and plugged into the device. So they can reboot the device, they can do password recoveries, they can upgrade the software over that modem as if they're physically on site. That would be really about the only time you would ever need a modem attached to a router or a switch or any other Cisco devices if you wanted to be able to access that modem to be able to connect to that device. Okay? And you can see there's this is a US Robotics modem. US Robotics is typically what's recommended. It's got this DB25 connector, which is my RS-232. And I'll take my RJ45, I'll plug it into my aux port right here. And I'll take my DB25 connector and plug it into my modem. And then on the other side, I'll have an analog phone line, PSTN phone line that goes to the modem. All right? Is there a practical difference? We have a question online from Pedro. Is there a practical difference between SSH version 1 and version 2? Absolutely. Primarily, well, first of all, SSH version 2 is much more efficient, dealing with flow of traffic and flow control for the data. But SSH version 2 also supports much higher cryptographic standards like AES, whereas SSH version 1 can be limited to different, kind of less mainstream or less, cryptographic standards that have a much smaller key space, right? So we generally do recommend the use of SSH version 2. We'll talk about that, though, when we get into the configuration of SSH a little bit later on. What about for out-of-band management? What port do they use? Out-of-band, we're going to be using the console port, typically. There is no option for out-of-band management on a network interface unless you dedicated a port specifically as a management port in a completely separate IP network, which is extremely rare. Most people don't do that, right? And by the way, we're not running any protocols, traditional protocols on our out-of-band ports because we're running serial protocols like RS-232 or VT100, terminal emulation programs or terminal emulation protocols. All right? All right. So what kind of terminal emulation programs can we use? PuTTY, P-U-T-T-Y. T-T-Y means terminal, like VTY. Terraterm, Secure CRT. If you really want to be punished, you can use Hyperterminal. That's the Windows terminal application. PuTTY is probably the most common. All right. It's free and very useful, very easy to use. But there are many, many different types of terminal emulation programs. The thing about these programs, though, they all do the same thing. They all use serial protocols. All right, let me show you PuTTY real quick. Maybe. There we go. So here is my PuTTY application. I opened it a few too many times, right? And you can see that for serial, we have different protocols that we can emulate, different settings, flow control, on or off, none. And we can specify different protocols that we're going to use. I'm not going to go through all the settings in PuTTY, but PuTTY is a very simple program to use. It's a self-contained executable. You don't have to install anything. Very, very easy to use. Okay? As far as on the exam, though, you're not going to test it on different emulation programs. People have different opinions about what protocol or what programs they should use. It just depends on what you're comfortable with. Secure CRT is great as well. The problem is it's a licensed product, so you have to actually purchase it. So, okay? So now we get into the command line here. Let me go into my router. All right? And let's talk a little bit about how to navigate through the command line. This is kind of an interactive discussion. So as I do things, you guys can go ahead and do things the same thing as well. Ask questions if you have questions. The first thing that you need to understand is when you access a Cisco device, there are different modes of operation. You have to pay attention to the mode that you're in because that mode determines what you can or cannot do on that device. Does that make sense? That mode of operation determines what you can or cannot do on that device. Now you can see a couple of modes defined already on the slide here. Privilege level 1, privilege level 15. Okay? So let me show you the difference. So you guys are in your device. It says router, but you see the greater than symbol there, right? This greater than symbol tells me what mode I'm in. If I type show privilege, I can see that I am currently in level 1. Now there is a level below level 1, it's called level 0. But level 0 you can't do anything in. In fact, there's only 5 commands that are available for level 0. So we never operate in level 0. In level 1, we have some limitations as well. We can't configure the device at level 1. We can't manage the file system at level 1. We can only do basic show commands at level 1. Show commands are what we use to see things about the platform. All right, so level 1 is what we call user exec mode. And you can see that depicted on the slide here, user exec command dash router. Okay? Pretty much a very limited function of operation. Nothing that you guys are going to be doing for configuration and operations will happen at level 1. But that happens to be the default mode that you're generally put into when you're connecting to your devices. Conversely, level 15 is the highest level of operation. When you go to level 15, you're in what we call privileged exec mode, meaning that you have the keys to the kingdom. You can do anything at level 15. You can configure the device, you can reboot the device, you can delete files, you can manage the file system, you can do any show command, you can run debug commands. Pretty much anything you need to do is at level 15. So the very first step that you guys should always perform when you're accessing your devices is to go to some privilege level prompt. Because if without that privilege level, you're going to be limited to what you can do. It's a progression, by the way. You can't just simply go into config mode without going to privilege level 15 first. Okay? Now we're making the assumption that we haven't done any customization of the levels and we haven't changed, we don't have any kind of TACX or radius or some sort of role-based access control configured. I'm talking about basic operation. The question online, which router do you want us to use in Packet Tracer? It doesn't matter. It doesn't matter. Could be a router, could be a switch. We're just going to be doing some navigation through the iOS, so they're all going to be the same. Okay? In addition to these 2 primary levels, we have some sub-levels. The next level I want to talk to you about is what we call global configuration mode. Global configuration mode. I'll tell you guys how to get into these modes later on. Don't worry about that right now. In order to configure the device, you have to be in some sort of configuration mode. Now, the base configuration mode is what we call global configuration mode. Global configuration mode. All right? In order to make any changes to the configuration of your platform, you have to first start at this mode of operation. Now, you'll notice that you can tell that you're in privilege mode by the #. You're in global configuration mode by the config #. Okay? Then you have these various sub-configuration modes. Here's an interface sub-configuration mode. Here's a router sub-configuration mode. Here's a line sub-configuration mode. Now, I'm not going into a whole lot of detail on these right now because we're going to be doing a lot of configurations throughout this week. In fact, we have about 2 hours left today. We'll be doing a lab for the rest of today. And then tomorrow we're going to be doing a couple more labs. So we're going to be doing a lot with these different modes of operations. Okay? Always pay attention to the mode that you're in, because the mode that you're in determines what you're allowed to do and not do. The biggest mistake a lot of people make when they're doing configurations for the first time is they're trying to execute commands in the wrong mode of operation. So very important to pay attention to the mode of operation you're in. I haven't told you guys how to get to these modes yet. I will show you that. Don't worry, we'll get there. All right? So user mode has the greater than symbol. Privilege exec mode has the pound symbol. And obviously, in order for me to do anything on my platform, I need to move from user exec mode into privilege exec mode. How do I do that? I use the command enable. So if you guys are in your platform, if you're at the greater than symbol, if you type the command enable, you notice that you will now switch to privilege exec mode. If I type show priv for my privilege, you'll notice that I am now in level 15. You also notice it didn't ask me for a password. Right, and by default, those passwords don't exist, at least not in routers and switches. Okay? But now I have the keys to the kingdom. I can do anything I want to do in this mode of operation. If I type disable, it will take me back to, disable, it will take me back to user mode. All right, enable takes me to my privilege mode. Okay? Now, in the example that we see on the screen here, there was a password set. So in this case, we had to enter the password to get from user mode to privilege mode. Okay? So don't worry about the syntax specifically on this slide. That's not the purpose of this slide, is to understand what's happening with this configuration. The purpose of this slide is to understand the progression of configuration. You can't do anything from user mode, so we type enable to go into privilege mode. I can't change the configuration of the device in privilege mode, so I type configure terminal to go into global configuration mode. Notice the prompt changes every single time I switch modes of operation. Configure terminal means I'm going to configure the device from the terminal application, which is PuTTY or whatever we're using. Okay? Configure terminal. All right? If I type in an interface, you'll notice the prompt changes again. So in this particular case, I'm in config-if, which means that anything I do at this prompt only applies to that interface. Does that make sense? That's called the sub-configuration mode. You can think of it like a hierarchy. It's the steps that we take to do our configuration. Okay?
I have a question.
Sure. Go ahead.
Let's say I have VLAN 1, VLAN 2, VLAN 3, and after I went to configuration and interface, but it's going to say in a config-if-1 or 2 or 3?
No. Interface configuration mode, regardless of the interface, is always config-if. It could be gigabit Ethernet, it could be fast Ethernet, it could be serial, it could be VLAN. It's always going to show as config-if. You'll never know specifically what interface it is by the prompt. You need to know by what you type to get to that prompt, but there is no distinction by the prompt as to what interface you're in. Does that make sense?
It makes sense. So I have to go back to whatever I typed.
To get to that mode.
Exactly, to know where I am exactly in the
Correct.
terminal.
Yeah. So pay attention to that, right? Because you want to make sure you're configuring the right interface. Okay? The second example, same thing, configure terminal, takes me to global configuration mode. In this case, I'm configuring my VTY lines. Again, the syntax is not important here. The purpose of this slide is to identify the prompt and how the prompt changes depending on what you're doing. Notice now I'm configuring my lines, config-line. And, oh, and by the way, you'll notice that I was able to switch from one mode to the other without going back to the main mode, privilege mode, or global configuration mode. Okay? Now, I don't expect you guys to understand completely at this point this navigation concept, but trust me, we are going to be doing lots and lots and lots of lab exercises. So this stuff that we're talking about now, by the time the class is done, will seem like second nature. Because, quite frankly, just like with anything, the best way to learn something is to do it, right? And to mess it up and fix it and do it again. That's really the best way to learn, right? Yeah, so we're going to be doing this quite a bit. Okay? Another thing to keep in mind is the way that Cisco structures their commands. In general, well, this is the case for most of Cisco commands. They will structure their commands to go from the more general to the more specific. Okay? So, for example, ping is a general concept. I'm going to generate a ping. Who am I going to generate that ping to? I'm going to generate that ping to 192.168.10.5. Or what about show IP route? I want to see something on the route. I don't know what. I want to see something. That's very, very vague, very general. I want to see something within the IP protocol stack. Again, more general, but not as general as show. What do I want to see within the protocol stack? I want to see the routing table. And what routes do I want to see within the routing table? I want to see the EIGRP routes. So you can see the structure there. I go from the more general to the more specific. Okay? I bring that up because it's something that helps you when you're trying to navigate through commands. If you keep that in the back of your mind, you start to think in that way and you say, okay, I want to see something so I know that's a show. Is it about IPsec? Is it about IP? Is it about IPv6? What is it? And then so on. All right? We'll spend plenty of time going through the command structure as we continue on. Another aspect to configuration is something called context-sensitive help. The question mark. Okay? The question mark is used to identify how commands are structured, right? So here am I, my router. I'm at this prompt. I want to be able to identify any command that I can type at this prompt. If I hit the question mark, it lists all the commands that are available to me at this prompt. Okay, and as you can see, there are a lot. On the left, I see the actual command. On the right, I see a description of what that command does. Yours is going to look a little bit different because you're using packet tracer, but same concept. At any point, you can type the question mark. Let's say, for example, dang it, I know that I need to configure the clock, but I can't remember the syntax for configuring the clock. But the command starts with a C. Let me see if clock is an available command at this prompt. So I type C question mark, and sure enough, clock is listed. But you also see calendar, clear, connect, call home, etc. Okay? Again, you guys won't see all these in your device because Packet Tracer is a simulator. It doesn't have all of the commands. I'm using GNS3. Okay? What if I want to see all the commands that start with CLO? Hey, how about that? There's only one. Okay? But, okay, so I've decided, all right, the command is clock. The command is clock, but I don't know how to set the clock. I don't know what the syntax is. Well, guess what? Type a space and a question mark, and then I get the options for the clock command. These are what we call subcommands. I can do a clock read dash calendar, I can do a clock update dash calendar, or I can do a clock set. Hey, how about that? I want to set the clock. So that's probably the subcommand that I want to use. So I type set, space, question mark. Basically what I'm doing here is I'm simply walking through the command. I'm walking through the command. All right? Clock set. Oh, it wants the time. What format? Hours, minutes, and seconds. 11, 11, 11. Now what? Well, let's see. Oh, I have two choices now. Now, when you see more than one choice, you can choose either one. They don't have to be done in order. I can set the day of the month using a number, or I can set the month of the year using a name. Now, you can tell that this is a name and not a command, because commands always show up in lowercase. Names, when they want you to replace something with a name, it's in uppercase. Does that make sense? So month is not a command. They want you to replace month with the name of the month for the year.
Not like 12.
Not like 12. If it was 12, they'd have a 1 through 12. All right, so I can say 27 January. Next, they want the year. Of course, the world started in Cisco speak in 1993, and the world's going to end in 2035. All right? So we're going to say 2035. Now I've set my clock. And I'll get a message indicating that the clock is set. All right? What's the point of this discussion? The point is, use your question mark. When you guys are doing lab exercises, you're going to make mistakes. You're going to type commands incorrectly. Pay attention, and if you have a question about what you're doing wrong, use your question mark. I'll show you some examples of that in a little bit. The question mark does work on the exam as well. Hopefully you won't need it, but it does work on the exam. So we see an example on this slide of walking through. The other thing that's going to happen is you're going to mess things up. You're going to type commands incorrectly. You're going to configure things incorrectly. So there are three things that I want you to pay attention to. Three different console error message types. Incomplete command, ambiguous command, and invalid input. All right, let me demonstrate. Clock set. Incomplete command. Now what that tells me is that what I've typed up to that point is valid. But I'm missing arguments. So I hit my up arrow, and I hit the question mark, and sure enough, I can walk through the arguments. The other thing that you might see is C set. Okay? Now this brings us to a secondary discussion. In Cisco, you can abbreviate any command as long as you put enough characters in that command to make it unique. C is too ambiguous. Why? Because there are several commands that start with the letter C. Even CL set is ambiguous. Because if I do a CL question mark, the router doesn't know if I'm trying to run clear or clock. Does that make sense? But I can do a CLO, S, right? 11, 11, 11, January 23rd, 2035. See, that worked. Why did it work? because there are no other commands that start with CLO at the prompt, and there's no other subcommand that starts with an S other than set. All right, you can abbreviate any Cisco command as long as you type enough characters to make it unique. Now I try, when I do my demonstrations and when I'm working with labs with the students, I try not to abbreviate the commands because I want you guys to see the commands in their entirety. All right, but you guys can abbreviate commands, and abbreviated commands work on the exam as well. Now the last error message you would see, clock sat, if I could type, is this one. Excuse me, now I get to see it twice. Invalid input detected at the circumflex, or the caret. It's technically called a circumflex, but invalid input at. And it tells you exactly where your command went wrong. That's what the marker is supposed to indicate. Now, it doesn't mean that that's the only error. It means that that's the first place there's an error. Now, I've taught this class thousands of times. And one of the things that I've seen the students do on a regular basis is they get into the mode of typing commands and hitting enter and moving on to the next command to the point where they're not actually paying attention to the screen. And they say, well, I took that command, but then they don't realize that there was actually an error, right? And they didn't notice there was an error because they were already typing the next command. Okay? So pay attention to the outputs. Invalid input detected at, ambiguous command, and complete command. All right? And these outputs will be, will identify where you're making a mistake. Okay? A couple of other shortcuts. The tab completion. Tab is great. I love tab. Right? Config T. Right? Interface. Fast Ethernet. 00. What's happening is I'm typing the first few letters of the command, and I'm hitting the tab key, and it's filling out the rest of the syntax. Okay? You'll see me to do this a lot when I'm doing the demonstrations, because I've gotten myself into the habit of always hitting that tab command, or the tab key. And by the way, don't type the word tab. I've had a student do that before. Use tab, and they typed the word tab. It was pretty funny. Why is using the tab command useful? Or the tab shortcut, I should say. Because if you're hitting tab and nothing is happening, then you're not doing something right, right? If I type IN tab, let me exit out here, IN tab, and it works, great. If I type ITab and it doesn't work, then that means that it doesn't recognize that command. And guess what? I is ambiguous, right? Or incomplete in this case. So tab is very, very useful. Control R I don't really use. I use the up arrow for my history. Control A I use a lot. I use Control A all the time, right? So oftentimes if I go into an interface, for example, and I say description, this is my interface, all right? To negate commands in Cisco, we put a no in front of them. Now I could type no description, this is my blah, 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 or I could just hit my up arrow, hit Control A, and put the no in front. Control A takes me to the beginning of a line. Now you guys are not tested on these shortcuts, so I don't want you to get freaked out that I'm going through these and showing you them, but you get used to using them. As you start to do configurations, as you start to do more and more with Cisco IOS, you'll get used to using these shortcuts. They're very, very useful. Okay? There is one that's highlighted here, though, the break sequence. And I want to show you guys this, too, because you guys are going to run into this in Packet Tracer. You're going to type something incorrectly, and Packet Tracer or the router is going to think that you're trying to do a DNS query or look up a host name. Control-Shift-6 breaks that process. On a real router, it's Control-Shift-6 and then push X. That is the break sequence for a Cisco device. Okay?
Break sequence, that means to stop.
To stop whatever's happening at that time. If you're doing a ping, trace route, if the router's doing a DNS lookup, Control-Shift-6 and then X. All right? You cannot run show commands or debug commands from configuration mode. Because that will happen. Oftentimes, let's do IP address, 1.1.1.1. Oftentimes, you want to verify that your configuration was done correctly. So you'll do a show IP interface brief, and it won't let you do it because you're in config mode. You put a do in front of it, and it works because you're telling the router to do it. All right? Do is just a quick way of being able to run show commands, debug commands, copy commands, stuff like that, without actually having to get out of config mode.
So show IP interface, that could be done on the user mode, not on the privilege mode.
No, show IP interface brief requires privilege mode, but not in config mode.
Not in config mode.
Right. Means, in other words, you have to be at the pound sign. Pound without config. Right? So you could do end, and then you could do a show IP interface brief. But then if you want to make a change, you got to go back into configuration mode, back into the interface. So if you do a do, you don't have to do that. Now later on, I'm not going to do that now, but later on I'm going to show you guys things like grep commands, how you can pull out pieces of a configuration by using the pipe. The reason I'm not showing you it now is because Packet Tracer doesn't support it. All right? GNS3 does, but Packet Tracer does not support what we call grep commands. So you guys are going to be running commands throughout the class. Some of those commands are going to be based on what's in the flash, some based on what's in the RAM, some based on what's in the working the NVRAM, and so on. All right? In fact, let me look up on the board here. Show CDP neighbor, show start, show run, show VLAN, show MAC, show ARP. Every one of these commands up here, you guys are going to know what it does after the end of tomorrow. Because we're going to do all these things. We're going to be doing a lot of configurations. Okay? All right. So, let's configure a basic network. If you have a device in your Packet Tracer, you can go ahead and delete that device, and we are going to build our own network here. All right? So to delete a device, just click the red X and delete the device. All right? So this is my Packet Tracer desktop. A couple of things I want to point out here. On the bottom left corner, you have your device categories. So routers, switches, hubs, etc. And as you click those device categories, you'll see the devices in the device window pane show up. If you want a device in your topology, you simply drag that device into your topology. So everybody click on switches, and we're going to drag in a 2960 switch, one. Okay, let me magnify mine here. And we're going to drag in another 2960 switch, 2. And you can make it pretty, put it where you want to put it. Okay. And what else do we need? We're going to put in a couple of computers, right? So click on your little end devices icon, drag a computer, and let's drag another computer. Okay? Now, it's challenging. We got a lot of people participating in this class, especially a lot of people online. So, if for any reason you get behind, don't just sit back and say, well, I'm just going to watch. Let me know. You know, it only takes a couple of minutes to get everybody caught up. But I want to make sure everybody's in the same position so we're all learning the same thing. So make sure you let me know if you need me to pause or if you need some assistance, okay? So you should have your 4 devices on your workspace. Now we're going to connect those devices together. We use the lightning bolt for our connection window. From switch to switch, we need to use a crossover cable. And if you look at our topology diagram here, I want to connect port 24 to port 24. Everybody use the same port numbers because if you're not using the same port numbers, then your lab's not going to match our lab and you're not going to know what the heck's going on. So let's go ahead and select our crossover cable. You don't drag that in, you just click it one time, click in the center of the device, and a window pops up with all of your interface numbers. We're going to scroll down and click 24, go to the other device, and do the same thing. And you'll see that the cable shows up between the 2 devices. Okay? Our PCs are connected to port 1 of each switch. So we'll do the same thing. In this case, though, we're going to use the straight-through cable, port 1 to our PC, and port 1 on the other switch to our PC Ethernet port.
So, I'm sorry, on the computer, when I click, it says RS232 or Fast Ethernet 0.
Of course, you're going to use Ethernet, aren't you?
Yes, I'm just making sure.
Yeah.
Thank you.
Absolutely, we're going to use Ethernet. Now, of course, this corresponds to what we would call physical layer in the real world. We're simulating this physical layer environment using Packet Tracer, but you're going to find that Packet Tracer is a pretty useful tool. Okay? All right. So rather than you guys online letting me know if you're done, anybody online that's not completed their topology, let me know. If I don't hear from you, then I'm going to assume that everybody's done, and we will move forward. I'm assuming most of you are done, so I would rather just know who's not done so that we can make sure everybody's on the same page. Okay? So what are we going to do with this topology? Well, we're going to set the names of our switches up. We're going to limit access to the device configuration by setting up security on our devices. We're also going to configure banner messages to show up on our platform when somebody logs in to manage our devices, and we're going to save our configuration. I know it's a very basic exercise, but remember, this is an entry-level course, at least the first part is. So we're assuming that you guys have never touched a Cisco device in the past. All right? So for some of you, this might be kind of basic, but it's still important that we start somewhere. So why would I give my device a name? Well, I could have potentially hundreds or thousands of devices that I'm managing. And the name often is an indication of what device I'm accessing. If I just left all my devices to router or switch when I'm accessing the device, it would be very difficult for me to identify what device I'm actually configuring. So we give names to our devices for that purpose, but names also play other roles. They can be used for DNS. In voice, they can be used to identify things like MGCP gateways. They can be used to generate RSA certificate pairs. There's all kinds of things these names can be used for. Couple of rules. Number one, the name has to start with a letter. It can contain no spaces, and it has to end with a letter or a number. And the only special characters you're allowed to have is a dash or an underscore. They can be 64 characters in length, but giving your device a name of 64 characters is not generally recommended. Okay? All right. So how do I give my device a name? Well, I'm going to show you the commands up here, and then I'm going to have you guys do it. First thing you have to do is you have to go into privilege mode. We know we do that by typing the enable command. Then we have to go into global configuration mode. Okay? Now, how do I know that the name command is done in global config? Here's the general rule of thumb. Here's the general rule of thumb. If the configuration that you're applying applies to the whole device, it's done in global config. If the configuration that you're applying applies to a specific component of that device, that's generally a sub-configuration, like an interface. Clearly, the host name applies to the whole device. So we go into global configuration mode, and we use the host name command to set the host name of our device. Let's go ahead and label it based on what we see on the diagram. The switch on the left, SW1, the switch on the right, SW2. All right, I'm going to go ahead and do that on mine. I click on the switch, window pops up, I hit the CLI tab, hit enter a couple of times so it activates the window. I'm in user exec mode, so I type enable. That takes me to privilege exec mode. Config T or configure terminal takes me to global configuration mode, host name SW1. Notice that configuration changed as soon as I entered the command. In this version of iOS, in this flavor of iOS, everything that you do happens immediately. When you change the configuration, it takes effect immediately. Okay? And let me go ahead and do the other switch. CLI, enable, config T, host name, SW2. End. Okay? So now when I'm accessing my devices, I know, hey, this is switch 2 and the other switch is switch 1. Okay? There's still some verification stuff that we're going to do, and of course, we're going to be locking down our platform as well, which is what we're going to be talking about next. One of the labs on the first exam, heavily rooted in the concept of securing the platform. So we're going to spend some time talking about that. There are 3 labs on the first exam. Neither exam has a configuration lab. Just show commands. You have to run show commands to verify the answers. Okay? So now I want to secure access to my device. As you've seen so far, we've been doing things. We went to privilege mode, we connected to the device. Not once did we get asked for a password. Right, and by default, those passwords don't exist. So obviously in a production environment, you kind of want to secure your platform, don't you? You don't want anybody to be able to just walk up and plug into your console and start doing configurations. All right? Now, there are essentially 2 types of passwords that you set. One, to get to privilege mode. That's probably the most important password. Because when you're in privilege mode, you can do anything. So securing access to privilege mode is very, very important. The second is getting to the device itself, either through the console or through VTY or through the auxiliary port. Okay? So we're going to talk about how to secure access to both of those. You can see here we have essentially four different things listed. Enable password, enable secret password, console password, and VTY password. Okay? Which one of these four options do you think applies to privilege mode access? Which one of these four options applies to privilege mode access?
The first two.
The first two. Enable, right? Either enable password or enable secret. All right, now I'm going to do a demonstration that covers several of the slides here, but it's easier to kind of demonstrate it and then talk about it because when you see it, it makes more sense. All right? And you guys just follow along here. I don't want you typing anything at this point. Just kind of follow along on the screen. Okay? So, config T, enable password, oops, Cisco. All right? So I have just executed the first of the four options. So if I type in and I type disable and I type enable, it's going to ask me to authenticate. Perfect. Great. Simple. I've now secured access to privilege mode. But why have two different options? Why have enable password and enable secret? All right, well, let me show you. If I do a show run, let me type the whole command, show running dash config. That shows me my active configuration. And you'll probably notice, as soon as it pops up here, something not so good. What is that? Anybody?
You can see the password.
It's written in plain text in my configuration file. Right, I can see the password. Now, if somebody's looking over my shoulder or somebody gets a copy of this configuration file, which is just a text file, they're going to see my password. All right? But if I use the new method, enable, it's new, we call it new, but it's been around forever. Enable secret Cisco 123, I have to make it different because it can't be the same. And I do a show run. When I use the secret option, the password is automatically encrypted using an MD5 hash, or message digest 5 hashing method. All right? So Cisco had a method before called enable password, which they've deprecated. They say don't use it anymore. Why it's still in, this is 15 code that I'm running here. It's still there. But Cisco said don't use it, use the secret option. Because the secret option is encrypted automatically. Okay? And what's even more interesting is if I change my password, do show run pipe include enable. That's a grep command. If I change my password, the hash is different even though it's the exact same password. It's a salted hash value, which means that it changes every single time. This won't happen in Packet Tracer because it's not running real iOS, but GNS3 is running real iOS, so it's acting like a real router. Okay? These are verifiable hashes, by the way. The thing about MD5 is there's two things. Number one, a variable linked input always results in a fixed linked output, 128-bit output. That's number one. Number two, hashes are practically impossible to crack. The only way to crack a hash is through brute force. using some sort of dictionary type of attack or rainbow tables or something to that effect that allows you to match hashing functions. Okay? Very, very simple mathematical computation going forward. Very difficult mathematical computation being reversed. Okay? So what's the bottom line? Well, the bottom line is if secret is an option, use it. If secret is an option, use it. Both of these commands protect access to privilege mode. But if secret is an option, use it. Now, what happens if I have both? You cannot use both. If you have both set, like you see here on the screen, once you set a secret password, the plain text option, even though it's still in the config, is no longer usable. Okay? But there's really no reason to use the plain text option. All right? Now we'll also see how to configure authentication for the console and VTY. VTY is what we would use to limit access to Telnet or SSH. All right? I'm going to demonstrate that in a little bit. Use the enable secret command, not the enable password command. Enable secret provides greater security because the password is encrypted. Now, there is a way in a Cisco device to encrypt plain text passwords. In fact, I'll demonstrate that. This is also a slide that you'll see in a little bit. It's called service password encryption. We'll see this in the slide in a couple of minutes. Okay? Service password encryption. Now, if I do a show run, pipe, include, enable, you'll see that the Cisco password no longer shows up. Instead, we see a 7 and we see a string of numbers and letters. Okay? I call this obfuscation, not encryption. It is technically encryption, but it's an old French encryption algorithm that was developed in World War II called Vigenère, which uses an F box or a substitution box to create the cipher. The problem is the substitution box, everybody knows it. It's been published for many, many decades, and it's no longer considered private or secret. That's the thing about cryptography. The cryptographic functions are generally well known. Everybody knows how AES works. Everybody knows how MD5 works. Everybody knows how triple DES works. What's the most important thing? The most important thing is the key. The key. And if you know the key or you know how the key is generated, then you can reverse that process. So in this particular case, it's not very secure. In fact, if I go and type enable password, and I make my password super long, oops, too many characters, still too many characters, there we go. All right, in fact, let's make it not only super long, but let's also put in some special characters. That's a pretty secure password, right? That'd be difficult to remember, difficult to break. And if I do a show run, pipe, include, enable, all right, I can in fact see that the hash, or it's not even a hash, the conversion, if you will, is pretty long as well. But I can take this now, copy it. Let me open up a browser here, Google, and Cisco password. Let's do, yeah, that one, that first one, password cracker. And I'll put in the ciphertext, and there is the plain text password, right? So not very secure. You know, this is not something that, this is not an epiphany, this is not something that I discovered that Cisco's not aware of. Cisco is very aware of this, right? This is why they say don't use the password option, even if you're using service password encryption, because service password encryption is not even strong. If secret is an option, use it. Okay? If secret is an option, use it. All right. Now, what if I want to secure access to my console port or my VTY lines? Then I'm going to go into those lines and set up a password. All right, look at the syntax. I'll have you guys do this here in a second. Configure terminal, that takes me to what? Global configuration mode. Line con 0 takes me into the interface that I'm trying to secure. In this particular case, it's the console port. You'll find that Cisco oftentimes identifies their ports using a number, and they generally start with a 0. Not all the time, but most cases. Okay? Now, the default configuration on the console is no login. That should be in quotes because that's actually the syntax. No login. Any idea what no login might mean?
It doesn't require a login password.
That's open, yeah. Doesn't require authentication. Okay? No login means you don't have to authenticate. The door is wide open. So the console is set up that way by default. So what do you think the word login is going to do? By the way, that's the command that you would type, right? Login. What is that command going to do?
It's going to enable to create a login.
It's going to require whoever's connecting to this port to authenticate. Notice it says logins are disabled until you set the password, because what I've done is I've said, okay, you're required to authenticate when you connect to the console. But if I don't give you a way of authenticating, then you're not allowed to authenticate. All right? So don't do the word login without setting a way to authenticate. In this case, setting up a password. All right? Make sure you put in the password. So go ahead and set up your console authentication. All right? Go ahead and set up your console authentication. Let's go ahead and set the password to Cisco in both cases for both switches. Let me demonstrate the first switch here. Enable. Well, let's set our enable secret password first, right? Enable secret Cisco. By the way, don't put a space at the end. Spaces are allowed in passwords in the Cisco world. So if you put a space at the end, you probably forget that it's there, and you cannot authenticate. All right? Line con 0. Login. Now, if I end my configuration now and I log out of the router, guess what? I've locked myself out of the console port because I haven't given myself a way to authenticate. Password, let's make that Cisco also. By the way, secret is not an option here, at least not yet. I'm going to show you guys later on how we can use secret as an option. We have to set up something called, well, local logins. We'll talk about that in a little bit. So now if somebody connects to my console port, let's do a show run, go to the end. If somebody connects to my console port, they're going to be required to authenticate using the password of Cisco. All right? I can do the same thing on line VTY. Now, VTY is what we use for Telnet and SSH. Take a look here, though. Why do I have two different sections for VTY? I've got line VTY 04 and line VTY 515. First of all, what does the 04 mean? Any ideas what 04 means? It's the range of ports, 0 through 4. There are 5 VTY lines by default. 515 means on this particular device, we have additional VTY lines. So there are a total of 16 VTY lines on this device, 0 through 4 and 5 through 15. Does that make sense? Now you can configure them all at once, 0 to 15, or you can configure one at a time, or you can configure 0 through 4. We'll just do 0 through 4. Same thing, login, password, Cisco. So now if somebody telnets or SSHs to this device, they're going to be required to authenticate. Okay? Do show run. You can see my console configuration. You can see my VTY configuration. Notice that line con 0 is left justified. I get to that through global config. Password and login are sub-configurations under line con 0, so they're indented. Does that make sense? The reason why you see two different VTY lines is because the default is always 5. 0 through 4, they're by default. You can't get rid of them. But in this particular platform, we have extended VTY lines. We have additional VTY lines. So 5 through 15 are just a continuation of the standard 5 that we have. At a minimum, every Cisco device has at least 5 VTY lines. Some of them have more, some of them only have 5. Okay? But you can configure these lines separately. For example, if I come in here and I say line VTY 0, no login, all right? If I do a show run, you can now see that VTY 0 has been broken out separately because I configured it different than the other VTY lines. Okay? You would never do that in the real world, by the way. Generally, you're going to configure your VTY lines the same. Reason being is you don't know which VTY line you're going to hit when you're accessing the device to do the configuration. All right? All right. Encrypting your passwords. We already talked about this. The service password encryption command. Its primary purpose is to hide all of your plain text passwords. Now this is important because it applies to the passwords that we set on our console port. Because we didn't have a secret option. We know it's not secure, but it's better than nothing. Okay? All right. The next thing we'll talk about is setting up a banner. Setting up a banner. What would be the purpose of having a banner on your platform? Generally, what is the goal of a banner?
To warn the user that they are in a secure area?
Yes. The key is what you said first, to warn. Right? Banners are there to encourage people not to do something, to encourage people to not do something that they want to do, which is bad, right? Okay, banners are used, and they have to have specific verbiage to do this, to discourage or dissuade somebody from breaking into your system, accessing your system illegally or whatnot. Now, technically, they don't do anything. I can put a sign in front of my house that says, "Beware of the dog," even if I have a Chihuahua, right? Or I can put a sign in front of my house that says NRA, or National Rifle Association, and that might encourage somebody to say, well, this guy's a gun-carrying person, I probably don't want to break into their house, even though I might be anti-gun. The idea is that we're trying to discourage somebody from doing something illegally, right? Now, that being said, there are other reasons to have banners. You can have banners to identify a system. Usually we don't want to put anything proprietary in there. You can have a banner that protects you legally if somebody breaks into the system, because you want to prosecute them, or if somebody steals your intellectual property. If your banner says welcome to my router, and that's it, and somebody breaks in and steals your intellectual property, you take them to court, what are they going to say? Well, the router said welcome, so I thought I was allowed in. And the judge is going to say, okay, that seems reasonable. Case dismissed, right? So banners need to have specific verbiage. They have to have specific wording in them to dissuade illegal activity, as well as to protect the owner of that platform in the event that they have to, prosecute somebody or identify somebody. Local jurisdictions are going to identify what verbiage needs to be in there. To set up a banner, you go into global configuration mode, and you type banner, MOTD. MOTD stands for message of the day. Now, here's the important part. You put in a delimiting character. It can be any ASCII character you want, as long as it's not part of your message. I used an @ symbol here. So I can put in now multiple lines. This is my system. Go away. And when I'm done typing my banner or my message, then I just simply type in my delimiting character again, and that completes the configuration of my banner. Again, that delimiting character can be any character you want, as long as it's not part of your message, not part of your banner. So now, if I exit the system, when I hit enter, the banner shows up. And I've locked myself out of my router because I changed my password to that crazy long password, but that's okay. You get the idea, okay? All right. Make sure that the banner doesn't include things like welcome. Like I said, technically it doesn't make a difference. Banners don't do anything other than act as some sort of warning message. All right? Okay. Now, unfortunately, this particular command does not work in Packet Tracer, but show control plane. Let me use my GNS3 router here. Show control plane. Oh, this version of iOS doesn't do it either. Never mind. I put this command in here because you're going to see this potentially see this on the exam. But one of the things that a lot of people aren't aware of is that their Cisco devices run a lot of services by default that might be considered insecure, right? For example, Telnet is turned on by default, right? DHCP Discover turned on by default. TACX is not on by default, but there are services that routers run that you may not want them to run. HTTP could be turned on. So we use this command, show control plane host open ports, to identify those services that are running so that we can either deactivate those services or secure them. Okay? Now, I would love to get into the discussion of data plane versus control plane versus management plane, but it's a little bit beyond the scope of this particular section. Let me just say that control plane are the higher level CPU functions that the device is running. The brain functions, you know, the high level functions. All right? What about network time? We know that the network time protocol, or time in general on a device, can be pretty important. Why is time on a device important? What kinds of things on a Cisco device are used for time functions? Well, logs, right? Events that occur get logged. They have timestamps. What about authentication? Authentication might be based on time. We can create access lists on the device that are based on time. Certificates for RSA are based on timestamps. So there are a lot of things that rely on the time on the platform in order for that platform to function. Now you can set the clock manually, but that doesn't scale well. If you have hundreds of devices in your network, setting the time manually on those devices is not very efficient. So there is a protocol that we can use called the Network Time Protocol, or NTP, which allows our devices to synchronize their clocks automatically to a clock source. It could be a cesium clock. It could be a line timing from a serial interface. It could be just another network device in the network that we're getting time from. Okay? NTP provides time synchronization between some sort of master clock and the device that's trying to achieve that timing standard. We can use GPS, atomic clocks, master clocks on the internet, and so on. Even routers themselves can act as NTP servers, and other routers can act as NTP clients, and they can synchronize their time. Very, very important concept that a lot of people don't necessarily think about when they're thinking about configuring their devices, is how to set up these time components. All right? Here's a very, very basic example. Now, there are a lot of things that you can configure with NTP, like authentication and strata level and different components of NTP that you can configure. We're looking at the very basics here. We have a switch that is acting as a NTP client, and we have a branch router that's acting as an NTP client, and we have an NTP server, right? A Windows machine or whatever running NTP protocol. It's very simple. Go into global configuration mode, type NTP server, and specify the IP address of your NTP source, clock source. So the branch router is talking to the NTP server as its clock source. The switch is talking to the branch router. All right.
So the switch can use the router as a server, even though it's a client.
Yes.
Okay.
A device can be a client and a server. Right. Like the hair plug guy. Not only am I the founder, but I'm also a client, kind of thing. Right. Okay. Now there are some other configurations that you most likely would want to put in. NTP is not very secure. On its face, you'd want to do some authentication and so on, but that's not really the goal of this particular discussion. This is very high level. We're not getting into the details of NTP configuration, but there are a lot of other things that you can do with NTP. If you want to verify NTP operations, show NTP status is perhaps the most common way of verifying NTP. And we can see from this particular output that we are synchronized. Now I want to talk about this for a second, stratum. Because the stratum that is defined defines the accuracy potentially of the clock source. Stratum 1 is the highest level you can have. That is a GPS clock or atomic clock or a cesium clock. It is a top level clock, meaning that it's generally going to be your source. Every time you go away from that source, so in our previous example, the branch router would be stratum 2. The switch would be at stratum 3. It's basically a time hop away from the original time source. The idea being that the further away you are from the original time source, the more likely it is that you'll have slips, excuse me, or differences in the time. All right. Now we can see in this particular case that we are synchronized. The drift is very, very small. I don't even know how to say that particular number in terms of seconds. It's not micro, it's even less than that. But you can see our drift is very, very small, which means that our internal clock is really not that different than our time source. All right. Now there's a question online. Is there a way to find out websites of NTP servers or routers? If so, can you sync without having access to the other location? The answer is yes. If you go to Google and you search on global NTP servers, you will find a list of publicly reachable and accessible NTP servers based on physical location or country. In the US, we use pool.ntp.org, but different countries have different NTP sources. You can also get clocking from physical devices, like a GPS component or whatnot. The second part of the question was so that you can sync up on it without having to access other location servers. Yes. Most of the publicly accessible devices don't require authentication and are very accurate. Google, for example, has some NTP servers that you can synchronize with. The Department of Defense has some NTP servers you can synchronize with. Okay? Now that timing may not be accurate or adequate for very specific timing functions, like in a TDM type network where you're running Sonnet or DWDM or some other function. You might need very, very accurate timing sources. But generally, most of those publicly available timing sources are just fine. All right? Make sure that you're using a reputable time source. The key here with timing is that the clients themselves don't get authenticated. The server gets authenticated. If you're doing NTP authentication, the server gets authenticated. The clients never get authenticated. Okay? We have a little bit left here. We have just about an hour left in class for today, but I do want to finish up this chapter before we wrap up for the day, because I want to be able to publish this online. Let me see what we have left here. We're going to do some basic configurations, and we got quite a bit left here, but we're going to keep pushing forward, all right? Quite a bit left, actually. We already talked about the concept of managing our file system. In fact, I showed you the show running -config command. The problem with show running -config, well, let me revert. The problem with making changes to your configuration is that those changes are not stored automatically. Every change that you make on your platform affects the running config, which is the configuration that's stored in working memory, RAM. So if the device were to reboot, you would lose that configuration. So one of the things that you have to be able to do is you have to be able to save that configuration. We use the copy command to do that. Specifically, copy source to destination. The configuration that's used by the device when it boots up is called the startup config. The startup config. Well, what did I do with this particular copy command? I'm taking a copy of my running config and I'm saving it as my startup config. Okay? So when I go into my device and I say copy run start, the first thing it asks me is, what do you want the destination file name to be? What you see in the brackets is the default. So you can just hit enter and it saves the configuration. All right? Okay? Now, if this device were to reboot, I would have my configuration stored. All right? Now, in a couple of days, we'll talk about the VLAN.dat. We're not going to talk about that right now, but on a switch, if you want the switch to go back to its default configuration, you have to delete that file. We'll talk about what that file is a little bit later on. Okay? We also know that devices have different ports and interfaces, right? You have a router, it's going to have fast Ethernet interfaces, it's going to have Ethernet interfaces, serial interfaces, and so on. Switches also have different interfaces. They have fast Ethernet interfaces, different types of interfaces, okay? But on a switch, we also have a special interface type. It's called an SVI, okay? Look at the, let me see, 1, 2, 3, 6 bullet point down. Cisco IOS switches have physical ports for devices to connect to, but they also have one or more switch virtual interfaces, or SVIs. These are not physical ports. These are ports that are created in software. We're going to actually configure these SVIs in a second here. But what is an SVI used for? Well, it has two functions. An SVI on a switch is either used to manage that switch over the network, or in a multi-layer switch, an SVI is used for routing, so that we can route from one VLAN to another. We'll talk about that part of it a little bit later on. Okay?
Question?
Yes, sir.
So for the SVI, can I have one of the SVI ports to be the management console port?
When you say management console, what do you mean?
Like out of band?
No.
It has
SVI ports are in-band. They're used for VTY. SVI is where we terminate our telnet or our SSH sessions to. The console port doesn't run a protocol, at least not a traditional protocol. It runs a serial encapsulation protocol, right? So the console port doesn't actually have an address. You can't assign an address to the console port. It operates essentially, for all intents and purposes, at the physical layer. Okay? So when we're creating an SVI on our switch, we're doing this for the purpose of establishing an interface that we can access through telnet or SSH. Okay? We're going to do this on our switch in a second. You guys have to do this because you don't have to do it on both switches. We can only do it on the left switch if you want. But because we're going to use this interface to create our sessions, our management sessions. So go into global configuration mode. Just watch up on the screen here real quick. and then we're going to do the configurations together. Of course, we know what config T means. Config T means we're going into global configuration mode. We're going to set up our SVI using interface VLAN 1. Now, I'm going to demonstrate something to you guys a little bit later, and I think it's extremely important that you understand. An SVI is not a VLAN, and a VLAN is not an SVI. Just keep that in the back of your head, and then I'll explain by demonstrating what I mean by that, okay? So we go into interface VLAN 1, we give it an IP address and a subnet mask, and we do a no shutdown to turn that virtual interface on, okay? Which means that we'll now be able to manage this device over the network using that interface address. So everybody go into the switch on the left in your topology. And I'm going to have to reset mine here. Hold on. Okay. So go into the switch on the left in your topology. All right. Make sure you have your secret password set. We already did that. Interface VLAN 1, and let's go ahead and give it an IP address of 192.168.10.2, 255.255.255.0, just like you see on the screen there. Now you can give the interface whatever address you want. It just depends on what your addressing scheme is for that particular subnet. But you can give your interface whatever address you want. For our exercise, we're using this particular address. Okay? Now, what I want you guys to do, did everybody get that configured? What mode are you presently in? What does the prompt say?
SW1 down.
You're not in config mode. You have to go into global configuration mode first by typing configure terminal, right? You can follow along what's in the book there as well, but you have to go into global configuration mode first before you can change the config. Okay? Once you're in global configuration mode, then you can go into the interface that you want to configure. Then you can add your IP address and turn on that interface. Now, we're going to be doing lots and lots of exercises throughout the rest of this lecture. Well, this lecture and many other lectures that we have to come. I want to make it very clear that I don't want you guys just to simply copy what I'm doing. Anybody can copy what somebody's doing. I want you guys to think about what it is that you're actually typing. Think about the commands that you're entering and say, why am I typing this command? What does this command do? Look at the command and say, oh, okay, interface VLAN 1. That means I must be configuring that interface. IP address, oh, that means I must be assigning an IP address to that interface. Does that make sense? So think about what it is that you're typing along with doing the exercise so that you can kind of solidify that in your mind a little bit. Okay? Now, let's go back to our packet tracer desktop. All right? Click on the computer on the left. Click on the computer on the left, and a window will pop up. You can see a pretty picture of our computer. Click on the Desktop tab. Desktop. and click on IP configuration. We can go ahead and give our computer an IP address, 192.168.10.10. We don't need a gateway in this case because we don't have a router, so we won't assign the gateway. Okay? Obviously, we're giving our computer an address so that we can test the functionality in a little bit. Okay? There's no save button, you just close it out. Now you can go to the command prompt on the same computer, and guess what? You can ping your switch. Okay? You can ping your switch, and you should get replies. If you don't get replies, let me know, because everything that we're going to do for the rest of this exercise is based on the fact that you have an SVI configured on your switch. So if you're not getting replies, let me know. Now the first one failed. Does anybody have any idea why that first ping failed? Anybody? That's exactly right, Daryl. Because of ARP, the Address Resolution Protocol. The packet tracer is smart enough to simulate that process. The PC had to discover the MAC address of the switch. If I do an ARP-A, I can see that I have the MAC address of the switch in my PC now. That's that Address Resolution Protocol that we talked about. All right? So we've created this SVI. Now, why did we choose interface VLAN 1? Because by default, every port on the switch is already in VLAN 1. But I want to be extremely clear about this, and I want to demonstrate this. An SVI is not a VLAN, and a VLAN is not an SVI. Now, we're going to talk about VLANs a couple of days from now, but if I come in here and I say interface VLAN 200, and I give that an IP address, you guys don't do this, but if I give that an IP address and do a no shut, great, I created interface VLAN 200, but guess what? If I do a show VLAN, there is no VLAN 200. Yeah, my formatting is all messed up here. Let me make this bigger and run that command again. Oh, there we go. Notice there's no VLAN 200. Just creating an SVI does not create the VLAN. And conversely, creating a VLAN does not create an SVI. They work together. But an SVI is layer 3. A VLAN is layer 2. We don't know anything about VLANs right now, so I'm going to leave the discussion at that. Just keep in mind that creating an SVI does not mean you're creating a VLAN, and creating a VLAN does not mean you're creating an SVI. The reason why interface VLAN 1 worked for us is because by default, on any switch, every interface is already in VLAN 1. VLAN 1 is a default VLAN. It cannot be deleted. It cannot be shut down. It cannot be renamed, so it always exists. All right? So we chose show IP interface brief. We chose VLAN 1 as our management VLAN because we knew it already existed. All right? What would be the purpose of this command? Well, before we get into that, let me ask you guys a question. If I'm on a computer and I want to access another computer outside of my subnet, what do I need configured in order for that to happen? If I'm on a computer and I need to access another computer outside of my subnet, What do I have to have configured on my computer to do that?
A default gateway.
A default gateway. That's right. I have to be able to get out of the network, and I do that by going to a router. Well, it's the same thing for a switch. If I've got a PC here connected to a subnet, a switch, we'll put in a little switch icon here. All right, let me use my finger instead. And that's connected to a router, that's connected to a switch over here. Okay? If I want to telnet from my PC to that switch, I have to have a default gateway configured here to get to the router. But if the switch wants to be able to go back to the PC, it also needs to have a default gateway configured. Does that make sense? We don't put default gateways on routers because routers route. And we're going to learn all about routing tomorrow because we start with layer 3 tomorrow morning. So the reason we put a default gateway on a switch is if we need to access that switch from a remote location. We're not going to do that in our case because we don't have a router in our network anyway, so it would be kind of pointless. Okay? This is not a route. It is not a route. Default gateways get assigned to layer 2 switches. Multi-layer switches, which are routers essentially, they don't necessarily need a default gateway. They might have something called the default route, but that's a completely different thing. Okay? Now, we're not going to type this in, but I wanted to give you guys an idea of the similar configuration that you would see with IPv6. And by the way, I'm a huge proponent of IPv6. So you're going to learn all about IPv6 in this class. Okay? So if I show you how to do something in IPv4, I'm probably going to show you how to do it in IPv6. Configure terminal, that takes me to global configuration mode. Check. Interface VLAN 1 takes me into the interface that I'm trying to configure, which takes me to interface configuration mode. Check. IPv6 enable enables IPv6 on that interface. Of course, you have to have a device that supports that. IPv6 address assigns the address to the interface. Now, this part of the address, you guys look at that and go, geez, what the heck is that? 2001:10/64? By the end of tomorrow, or before, by lunchtime tomorrow, you will know exactly how to read an IPv6 address, and everything you need to know about IPv6 will be talked about tomorrow. Okay? Of course, you know what no shutdown does. That enables the interface. Now, if I was to do this along with what you guys already did, that would be what we call a dual stacked interface. What does that mean, dual stacked?
Generally use both IPv6 and IPv4.
We're using both stacks, right, IPv6 and IPv4. Oftentimes when you're migrating to v6, that's what you're going to do. You're going to run both protocols at the same time.
When you do the IPv6 enable, does that enable it only for the interface?
Yes,
oh.
Only for the interface.
But if you do it like in global config, would it enable it?
There is no IPv6 enable command in global config.
Oh, okay.
There's an IPv6 routing command, but not an IPv6 enable command. Okay? All right? Now, there is no default gateway command in IPv6, so we use the IPv6 route command. Don't even worry about that right now. We'll talk about that a little bit later on. Okay? All right. The next thing that we talk about, of course, is enabling our platform for secure management. What is the default transport on all Cisco devices? Telnet, right? That's the default transport, but that's no good because it sends everything in plain text. So what we want to use is we want to use something called Secure Shell. Let's go ahead and do this as a group exercise. Everybody go into the switch on the left, okay? And I'm going to walk through what's in the slide, but we're going to do this step by step. What have we already done on this platform? We've set up an enable secret password. We've set up our password for VTY and console. We've set up a banner. And we set up an SVI. Now what we're going to do is we're going to configure our device for SSH. All right? Now there are two requirements that have to be met before you can configure SSH on a platform. Number one, the host name has to be unique. It can't be the default host name. That's what we've already done. SW1 is a unique host name. Number two, the domain name of the device has to be configured. All right? Config T. You guys follow along with me. You guys type these commands as we go. We're going to do all these commands together as a group. IP, domain dash name. I'm just going to make mine cisco.local. This domain does not actually have to be a real domain. It doesn't have to be resolvable. It doesn't have to be registered, but it does have to be set. And the reason why is that we're going to be generating something called an RSA certificate pair. Now, we're pushing, we got about 30 minutes left, and we're going to get through this, but I really feel compelled to talk to you about how RSA certificates work and how you connect to your device securely. So let's say here's my PC, okay, and I've got PuTTY running on this computer. It's connected to some infrastructure, and I want to manage a switch over here, okay? So I open up PuTTY, I type SSH, and I put in the IP address of this switch here. Sends a request on port 22 for establishing a secure session. Now here's what happens, okay? Here's what happens. First of all, SSH uses encryption, specifically AES, to hide all of the communication that occurs between those devices. The problem is AES needs a key to be able to do that encryption. I don't configure the key on the PC, and even if I did configure the key on the switch, how would I get the key over to the PC without somebody in the middle seeing it? Okay? So we use something called public key infrastructure for key establishment and key exchange, specifically RSA. RSA stands for Rivest, Shamir, and Edelman. Those are the three guys that came up with this architecture. Ron Rivest, I don't know what the other guys' first names are, but anyway, okay? And the fundamental concept of RSA is that we have two keys, essentially. They're certificates, but we have two keys. We have a public and we have a private, okay? What we call a public and private key pair. So, PC wants to connect to a switch using SSH. By the way, this is the same way it works with SSL and TLS and web encryption, HTTPS, all that stuff. Open up the SSH session. The switch sends the computer its public certificate. Okay? The computer generates the key and encrypts the key with the certificate. Okay? So and it could be 1024 bits, 2048, whatever. So I use this public key to encrypt the encryption key. Remember, that key is what I'm using for AES. I send that encrypted key to the switch, and the only way that you can figure out what that key is by decrypting that information with the private certificate, which corresponds to the public certificate. The only device that knows the private certificate is the switch. So this key comes over here, the switch uses its private certificate to decrypt, and now he has the key, and he has the key, and they can do their SSH communication. That make sense? It's the same way a web server works. When you connect to a web server, the web server sends you its public certificate. You then generate a key that you're going to use for SSL encryption, right? And you encrypt that key with this public certificate, and the web server decrypts that key with its private certificate, and now you have a shared secret key that nobody could see. Okay? Security is another one of my passions, but it's a little bit beyond the scope of this class. However, the reason why I was talking about this is because of this command right here. Crypto key generate RSA. This is where we're generating our private and public key pair. Okay? And that is done using the domain name and the host name. So if I go to my switch, crypto key generate RSA, it'll say, how large do you want this key to be? The minimum size you should be using by today's standards is 2048. So it says generating 2048-bit RSA keys, plural. Because what's being generated is a private and public key pair. And that's being stored locally in that router or that switch. All right? By the way, SSH is now enabled. Of course, we want to use SSH version 2 because it's better. So we say IP SSH version 2. That's going to allow us to use things like AES 256, and the flow control is a little bit better handled. There's some other differences. I'm not completely versed on all the differences, but there are some other differences as well. Okay? So far, so good. We've enabled SSH on this platform. All right, so let me go back to my slide here. We did, the host name was already set. We set our domain name. That was the second thing. We generated our RSA key pair using a minimum size of 2048, and we switched to SSH version 2. The only thing left is to set up the authentication on our VTY lines. We go into our VTY line, transport input SSH. This tells me that on the VTY lines, I want to only allow SSH. The default is telnet, right? So let's go ahead and do that. Line VTY 04. Okay, we know what that does. That takes us into our VTY lines. And I say transport input. What if I said all? I don't want you guys to put all, but what if I said all? Then that's going to allow any protocol. SSH, telnet, SLIP, other protocols. If I say telnet, that kind of defeats the purpose because that's the default. But if I say SSH, I have now disabled telnet on those VTY lines. Because I said the only way that you can connect to this device now is through SSH. We're not quite done. Almost done, not quite. Because the other thing about SSH that's important to understand is SSH requires a different authentication method. you can't just use a password to authenticate. You have to use a username and a password. So the next thing we do is we say login local. Instead of just login local. What that does is that tells the router or the switch, whoever's connecting to these VTY lines, you need to authenticate, but we're going to go ahead and authenticate you using a local username database, meaning a list of users that we configure on the device itself. All right, just a quick review. Host name has to be unique, number 1. You have to set the domain name, number 2. You generate your RSA certificate, number 3, using a modulus, a minimum of 2048 bits. In 2013, NIST published a document stating that 1024 is no longer considered secure. We're going to switch to IP SSH version 2 because it's better. We're going to go into our VTY lines. We're going to enable SSH but disable Telnet. And we're going to say you have to authenticate. But this time, instead of using the password, you're going to authenticate using usernames that we configure on the platform. Okay. Now notice what you can do with a username. You can use secret, which means that the passwords are hidden. That is the last step. Let's go ahead and exit out of line configuration mode. Username, I'm just going to put Cisco user, and secret Cisco. Now those aren't secure, but that's not the point here. Obviously you'd want to use secure authentication as well. Done. We've configured SSH on this device. Now we can test it. All right. Go into your PC, SSH-L for login. That's not a 1, it's an L. SSH-L, Cisco user, and then the address of our switch. And sure enough, I was able to SSH from my PC to the switch. Okay? Did yours work?
I haven't done it. I stopped with it on after I enabled IV SSH version 2.
Okay.
SSH version 2.
Right? So what are you missing? You have to set up your VTY line, right?
Yes.
Go ahead, it's fine. I'll give you a couple minutes to do that. All right? Now, keep doing that, all right? Don't stop because I'm just going to show something. Keep typing. But for those that it's actually working, you can actually do a show IP SSH, or show SSH, excuse me, and you can see the active session. And sure enough, I see that Cisco user is authenticated to this platform using AES 128 with block chaining mode. You got to take the CISSP or advanced security class to learn all about block chaining mode. But for those that are interested, since some people are catching up, basically we do encryption using blocks of data. There's 2 different types of encryption techniques. There are stream ciphers and then there are block ciphers. Stream ciphers do bit-by-bit encryption, and block ciphers encrypt data in blocks of information, usually 128-bit blocks. And that's what block chaining mode does. Now, it's a little bit more than that because there are some things like initialization vectors and some randomization that takes place. But anyway, we're using good encryption. 128-bit encryption. We're using a HMAC SHA-1, which is our hashing algorithm for message integrity with an authentication component. So we're doing some good stuff. Okay? These are all things that you learn about in the security class. Yes?
I did it all exactly, and I hit enter after N, and it says sys5-config-I configured from the console by console.
Yeah, that's just a message indicating that you change your configuration. Okay? So then you go to your PC. Sorry, I didn't know if you wanted that one in or not.
Okay, thank you.
You go to your PC and you open up your session using the SSH-L command. How are you guys doing online? Are you able to actually test it? Of course, you can always go back and view this video later and pause it and do it again and test it again. And that's the nice thing about having these recordings online is you can take your time. All right. Let's see how many troopers we have hanging with us. That's still 22. That's pretty good. I would have expected the number to go down significantly after given the time zones. All right. Okay. Now, I'm sure you guys have seen this message before. All right. Well, that message, not specifically that text, but you've seen a pop-up like that. That basically means that the certificate that you're receiving from the device has not been signed by a third party. So there's no way to verify that that certificate is actually valid. Okay? We're doing what's called self-signed certificates, where we're generating our own certificates. We're not actually purchasing a signed certificate from a certificate authority. I'm going to try and upload the videos tonight if I can. I'm going to try and upload them at the end of each day. But check our YouTube channel later tonight or first thing in the morning. Just go to YouTube and search on thinKtank Learning, and you'll be able to find our channel. Okay. All right. Some other basic stuff. We're pretty much done with the chapter. We just have to wrap up with a few extra slides here. Speed and duplex. We already talked about speed and duplex. You can set those values on your interface using the speed and duplex command. The default is auto in both cases. Most times auto is going to be just fine, and the devices can auto-negotiate speed and duplex, no problem. Okay? This is obviously something that you would do on the interface. All right? I will show you something, though. You don't have to type this, but I'll show you something that's interesting. With a switch, you can actually configure a range of interfaces at one time. So you can actually, in this particular case, I'm configuring interfaces 1 through 10. This works on switches because oftentimes a lot of the switch interfaces that we're configuring are going to have the same configuration. All right. You can also do commas and have individual interfaces as part of that group. So you could say comma FA 0/12. I don't know if this works in Packet Tracer. FA 0/15-18 and so on. That does work in Packet Tracer. Great. All right. So I did 1 through 10 and 12 and 15 through 18. So you can kind of mix and match the interfaces that you want to configure. You'll notice that the prompt is if-range. Just a little tidbit of information. Okay? All right. Now this is a very, very important concept. This command, show IP interface brief, is essentially like the Phillips head in your tool chest. You guys will be using this command all the time. In addition, this command is covered quite a bit on the exam. You need to be very familiar with what this command shows you. Okay? It works on a router and it works on a switch. Show IP interface brief. Okay? So let's break down this command. The first thing that you see obviously a list of interfaces. Okay? If the interfaces are layer 3, they can have IP addresses assigned to them. This happens to be a switch, so these interfaces are layer 2. They would not have an address assigned, but if it's a layer 3 interface, it would have an address assigned to it. You could see that here. The next 2 columns we don't really care about, the method and the status. That's almost always manual and almost always yes. In fact, it's very rarely not. Hey, that's 0011. The last 2 columns are the most important. All right? Status, layer 1. Protocol, layer 2. Okay? So if you're troubleshooting your network and you're trying to figure out whether or not your network is functional, we typically troubleshoot from the bottom up. Top-down troubleshooting can happen, but usually we only use top-down troubleshooting if we're troubleshooting an application. If you're troubleshooting the infrastructure, you troubleshoot from the bottom up. So if I'm having problems with the device that's connected to port 1, this output here tells me that I don't need to troubleshoot layer 1 and layer 2. Why? Because it tells me that layer 1 is up, which means there's a cable plugged in, and the interface is operational. It's getting a heartbeat, and that the data link layer is working. So Ethernet is working on the interface. Now, if I'm having a problem with a device connected to port 4, where am I going to start troubleshooting? I can already tell layer 1 is down. If layer 1 is down, what does that tell me? There's no need to troubleshoot layer 3. There's no need to troubleshoot the application. Until layer 1 is up, nothing else is going to work. Does that make sense? So this show IP interface brief command, very, very quick way of seeing whether or not layer 1 or layer 2 are working on your interface. Line status, which is the status column, is the layer 1 status. If the cable is installed, if it's the wrong kind of cable, is the other device at the other end of the cable turned on, that kind of thing. Protocol, if it's down, that means that we're having probably a mismatched protocol. We don't typically see that on a switch, but we might see that on a router. If one side of a serial link is running PPP and the other side of the serial link is running HDLC, that could be a problem. It would be a problem. Okay? So when we're doing our lab configurations from this point forward, and as we progress through more and more lab exercises, I'm going to do less with you, and I'm going to assume that you guys are doing the basics. All right? Well, this command, by the way, it's on one of the labs on the test as well, on ICND1. This command is like the Phillips head in your tool chest. We use this command all the time. Okay? All the time. Probably one of the most important commands from the class. What are the other types of status codes that I may see? We know what up means, right? All is well, the interface is functioning at layer 1 and layer 2. Down means all is not well. Most likely it's a data link layer problem because the physical layer is reporting up. Down is pretty bad because that means that not only is there no data link layer, but there's no physical layer. What is the difference between down and administratively down? Down means the interface is turned on, but it's not functioning. Administratively down means that the interface has been shut down.
I mean, the device totally down.
No, the interface has been shut down. You can go into an interface and you can type the command shutdown and it will turn off those interfaces. How do you reverse that? No shutdown turns the interfaces on. Okay? So administratively down means that you went into that interface and you typed the command shutdown, which means you disabled that interface. By the way, that is the default on routers. All the interfaces on routers are shut down by default out of the box. On switches, that's not the case. On switches, the interfaces are enabled by default out of the box. Okay? All right. Did it again. Okay, we're back in business. I don't know what happened there. Skip to slide number 3 for some reason. Okay. Ping, we know what ping is used for. Ping is an ICMP message that allows us to test reachability. We're going to learn more about ping later on and what types of pings we can run to test connectivity. Of course, we already did this to allow us to identify reachability. Okay? When a switch boots up, it goes through a certain process. Now, you will absolutely be tested on this boot up process on ICND1, the 100-105 exam. All right, so let's walk through this process of how these devices boot up. So you power on the device. Oops. You power on the device. And the first thing that that device does is it checks something called the configuration register. Basically, the configuration register is used to identify how the device boots up. Now, if it's left at its default, which is hex 2 or through hexf, so 0x002 or whatever, through hexf, it's going to boot up normally. It's going to look for boot commands, which we'll talk about later. Those boot commands do not exist by default. And then it's going to load the iOS image. If you don't have boot commands, which you don't by default, it's going to look for the iOS in Flash, which we talked about already, right? We know that the operating system is stored in Flash. If there is an image in Flash, what does it do? It loads the very first image it sees in Flash. Now, you can have more than one image in Flash. If you have more than one image in Flash, you would have to set up these boot commands to tell the router or switch which image you want to use. If you don't, it simply loads the very first one. If it cannot find an image in Flash, it says, okay, can I load an iOS image from a TFTP server? Which, by the way, is also something that's not configured by default. You have to set up the TFTP parameters for that to work, which is a protocol that we use to get information over the network. If I can't find an image in Flash and I can't find an image in TFTP, I go into recovery mode, which is called ROMMON. ROMMON is a read-only memory monitor, or remote, or what we call ROMMON. Basically, it's not a good position to be in. That means that the device is not functional. But in ROMMON mode, at least you can perform some recovery functions to try to fix that device. Now, once the iOS has loaded, what's the next step? Once the iOS is loaded, then I start to look for the config. That's right. Okay? Once the iOS is loaded, I look for the config. Now, in order to find an image to use, we look in Flash. All right? If the boot variable is set, by the way, this is the syntax to set the boot variable, it will use that image. You can see there, in this case, I told the device to use a specific file stored in flash to boot up. When would you use this? Well, typically you would use this if, for example, you have a router or a switch you're upgrading and you wanted to switch to the new version of code. You would use the boot variable to tell that device to boot from that new version of code instead of the old version. If the variable is not set, like I said, it's going to load and execute the first file it sees in flash. Now, once that's done, then we look for our configuration file. Where is that configuration file stored? In NVRAM. So this is a new thing that we haven't talked about before. NVRAM stands for non-volatile random access memory. Random access memory means that you can write to that memory, you can read from that memory, you can erase files in that memory, but non-volatile means that if you lose power, the contents of that memory remain. Okay? Well, that's where the startup config is stored, in NVRAM. So the device goes and it tries to find the NVRAM. If there is a startup config, it goes ahead and loads that startup config. If there is no startup config, it may try to load a config from TFTP, or it goes into setup mode. You guys saw that when you were playing around with the router earlier. It said, would you like to enter initial configuration dialog? You guys remember that? Yeah. Okay? We're going to see this again, by the way, later on. We're going to start to do configurations on routers. You'll see this process. Okay? All right. So let's just recap. When you power on a Cisco switch, the first thing it does is tries to load the operating system. Where is that operating system stored? In flash. Yes. Where is the operating system loaded to?
To the RAM.
To the RAM. Once the operating system is loaded, then the router or switch tries to load what? The startup config. Where is the startup config stored? NVRAM, non-volatile RAM. Okay, non-volatile RAM, which, by the way, is just a partition of flash. All right? All right. If you want to recover from a system crash, there might be an instance where, for example, you forgot the password for your device, or the device is not booting correctly for some reason. On the front of a switch, there's a button called the mode button. Let me see if I used to have a picture of it in here, but it's not here. Let me pull one up for you guys. Okay. Cisco 3750 and images, and let's do large one here. Okay, so if you look at the front of a switch, there's a panel on the front of this switch here. See this panel in the left corner? There's a button here called the mode button. Okay? Each of these LED indicators show different things, like the status. If it's a stack, is this the master switch? If it's providing PoE, etc. But that mode button is your recovery button on a switch. You hold down that mode button when you plug in the switch, and the switch bypasses all of the boot up process, and it goes into ROM-mod mode. At this point, then, you can start to do things like password recovery. You can delete the config file and so on, so that you can recover the system itself. Okay? It's a little bit more detailed than that, but that's all we need to really say about that process. The last thing we'll talk about in this chapter, before we wrap it up is file management. That is also something that you're going to be tested on quite a bit on the exam. Okay? File management. You know already that there are many locations where files get stored. All right? Well, we use the copy command to manage that file system. The syntax, and this is very important, copy, source to destination. Copy, source to destination. Okay? You would definitely be tested on this on the exam. Now, there's an application that we use to manage our files in a Cisco device. It is called TFTP, Trivial File Transfer Protocol. It is the default application. It's not the only one we can use, but it's the default application that we generally will use to manage our file system. Some routers support SCP, Secure Copy, some support FTP, some support SFTP, but TFTP has always kind of been the default. It's very easy to use, very lightweight, and so on.
I have a question on this slide.
Yes.
So the 6 points right here, they are in sequence to do?
No, they're not in sequence, they're just examples.
Oh, examples of copying.
Yes, and we're going to talk about each one of them. Because that's what they're going to test you on. They're going to say, okay, what does this copy command do? Or if I want to do this, what command would I use? Okay? So you wouldn't use these in sequence, these 6 commands. These are just examples of file management. For example, if I say copy run TFTP, I am taking my running config and I'm copying it to a TFTP server, right? Which is my external server. That was weird. Okay? Source to destination. By the way, if you see the word backup on the test, think TFTP. Because that's essentially what I'm doing. I'm creating a backup copy of my running config. What about number 2? Copy TFTP run. What am I doing in this case? Copy TFTP run. What's the source? TFTP. What's the destination? Running config. So what am I doing in this case? I'm restoring a configuration. I'm taking a configuration from backup and I'm making it my working configuration. Does that make sense? What about copy start TFTP? Pretty much the same as number 1. I'm just creating a backup of my startup config. Copy TFTP start. I'm replacing my startup config with a file on my TFTP server. So what about this one? Copy flash TFTP. That's option number 5 in the list, copy flash TFTP. What does that command do?
I'm copying the TFTP from the flash hard drive.
I am copying something from flash to my TFTP server.
It's here, I'm sorry.
Right?
You got it now, yeah. Yeah, the source and the...
Now, what's interesting is this is the actual syntax. Notice I didn't really specify what the files were. I didn't specify the IP address of the server, anything. That's because when you execute this command, it starts asking you those questions. It says, okay, what's the file in flash that you want to copy? I give the name. What's the address of the TFTP server? I give the address. What's the file destination name? In other words, what do you want that file to be called on the TFTP server? Okay? We use the copy command to manage our files. All right? This next slide shows kind of a representation of that as well. In this slide, though, copy run start, we're taking our working config and we're making it our startup config. Simple enough. Copy start run, the opposite. Taking our configuration in NVRAM, and making it our configuration in RAM. All right, so this is just a flow chart to kind of represent the same concept. All right. Another command, show file systems. You'll probably never use this command in the real world, but show file systems shows me how much memory I have, how much active memory is being used, how much memory I have left over, and so on. Very useful command. Not really, I'm being facetious. Okay. The last thing we'll talk about, literally the last slide I believe in this, is how are files named with Cisco? Because you'll see they have, pretty long file names. C2900. That's the model or the platform. The feature set. Does it support voice? Does it support security? Does it have cryptographic functions? MZ is the format of the file. In this case, it is compressed. SPA is the file signed. That's called a digital signature. We use an MD5 hash to sign files so that we make sure that we're using secure files. And then we see the version number and the extension. Binary executable means it's an extractable file. It's compressed, but it can be run uncompressed and extracted. Okay? All right. A lot of the platforms that we have today also require special licensing. Now, I put this slide in here just to give you an idea of how the process works. If you want to see what licenses are supported on a platform, you use the show version command. We'll talk about the show version command a little bit more tomorrow. But in the newer platforms, you're required to purchase licenses to run certain features like voice or security or other types of features. So how does that work? Well, first thing, you purchase the license from Cisco. They send you an email with something called a product activation key. You go out to Cisco.com, you use the UDI, the unique device identifier, which is generally the serial number. Let me see if this, I know it doesn't show up in Packet Tracer. Let me see if it shows up in GNS3. No, it doesn't. Well, it might show up in Packet Tracer. Let me just check real quick with a 2900 series router. 2901. Because I want to show you guys this if it's available. Remember, this new licensing option came about in the 900 series platforms. We didn't see this in the 2800 or the 2600 series. Show version. Yeah, so it is here. Okay? So, show version. And what you see is product ID and serial number. Normally you would see the UDI here. That's not being reported by Packet Tracer, but it would show up there. That actually, the UDI is just a combination of the product ID and the serial number. Okay? Notice here there are essentially 4 technology licenses that are available. IP base exists no matter what. But then you can also get security, unified communications, and data. Data is like advanced routing features, service provider type features. So these are the 3 types of licenses that you can get from Cisco. If you want to run voice applications on the router, you need a UC license. If you want to run security features like Firewall iOS, VPN, you need to use, get a security license and so on.
When we say a voice application, that means a phone system?
That means the router can act as a phone system, a voice gateway, run voice features, right? So anyway, you use that UDI, you register the license, and then Cisco sends you a file that you can install on the router to activate that license. Licenses with Cisco in the routers are permanent. In other words, you don't have to renew them every year. It's a one-time purchase. On calls, there's a renewal process, but not on routers. Okay? All right, to install a license, we use license install. Of course, you would have to copy that license to Flash first. Then you would install it from Flash, and it would activate the license. And you can see here are those 4 license packages that I talked about. How did we see those? Show version. Okay? Anything that was 12.x, we didn't have this function. We started to see this in 15 code. All right? So that concludes that chapter. I know that was a long one. I appreciate you guys sticking around. We're actually not too far off our schedule. It's only 5:44, so we only went 15 minutes past. But we're going to wrap up for today. Tomorrow's a big, big day, okay? Subnetting, routing, a lot of interesting things that we'll be covering tomorrow, okay?
So what's